Hello and welcome to another tentacle tutorial for After Effects. This one is going to be a follow-up to the previous one, so I would suggest watching that one first if you haven't already seen it, because we're going to be using that as a starting point for this one. So the reason I'm doing another video on this subject is I've had a few questions from the last one. Specifically, I received an email from Tim Thiessen, I think is how you say it. Apologies if I'm saying your name wrong. But thanks for getting in touch, Tim. And there were a few questions that I'd like to try and address regarding how to take this basic version of the tentacle and make it look more like the one in my original example. So the things we're going to cover are adding the little suckers and specifically having them rotate so that they are oriented properly along the curve. Another question was how to keep certain points on your shape sharp whilst all the others get nicely rounded. So particularly this point here on the upper surface of the tentacle is nice and sharp, whereas the rest is nice and smooth. So we'll have a look at that, and then a few little bits about the shading. That's nothing fancy going on there really, but we'll touch on that as well. So let's get started. First thing to do is keep things tidy. We'll call this one insensible tentacle bottom, and we'll make a duplicate of that to sit on top. And what we want to basically do is take this bottom row of points, and instead of offsetting them down away from our curve, we want them to sit just below the curve. So we're creating a layer which only covers half of the total shape. So let's do that first. And to make it a little bit easier to see what's going on, we'll just darken off this fill a little bit. Okay, so inside our path expression, this first set of points here are the ones along this bottom edge. So instead of multiplying them out by the same as we do on the top, we can actually divide these numbers by 10. So the first one gets a 0.1, and then these guys all need a 0 adding in like that. What you should see now, oh, I must have missed something. 0.1 that should be. Sorry about that. Okay, so now we've pumped these points back up, almost back up to the original level of the curve. So we now have two layers sitting on top of each other. And while we're at it, we're also just going to modify the path on the bottom layer as well to bring its top row of points down close to the curve. You'll see the reason for that a little bit later, but while we're doing it, we'll just do them both at the same time. So same again. Add a 0 in to divide this amount by 10. Same on here, 0.1. And there we go. So that brings us on to the second point, which was how to maintain a corner in this area here. We want this point here not to get rounded off by our round corners operator. Now the round corners operator does exactly what it says it's going to do. Any point which has no tangent handles, or has a 0 length tangent handle, is considered to be a corner vertex, and therefore it will be passed to the round corners operator and be smoothed. So what we're going to do is, at the moment we have empty lists in our expression for in tangents and out tangents, and what these are is for every point in our points list, you can specify an incoming tangent handle and an outgoing tangent handle for that point in order to create curvature in the curve itself. So what we need to do is maintain all of these guys as corner points, but explicitly declare this point up here as being a non-corner. So we're going to need a list to put in here, and for the most part that's going to consist of 0 length vectors. So we're talking about tangent handles, so let's go for t-list, create our empty list, and then in here we're going to create some 0 length vectors. We need one for each of our points. I believe we have 11 points. Now you will get an error in your expression if the number of points in your tangent list doesn't correspond to the number of points in your point list. It's fine to pass an empty tangent list, but it's if you are going to specify any tangents for any of the points, then you have to do for all of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now this is the very last point on our path because we're going in this direction. So for the very last one, instead of it being a 0, we want to add a very small value, 0.001. And what that's going to do is mean that this is no longer a corner point. Its appearance isn't going to change because the value we're putting in is so small. So what we need to do is, instead of this empty list in here, we need to pass our newly created list like that, and provided we don't have errors, we should see that last point sharpen up nicely. There we go. So for our top layer, we should be able to just steal this guy, copy that, paste it in here. But this time, for the top, it's not the last point on the mask; it's the first point on the mask that we want not to be a corner. So we add our little value in there, and then we remove it from there. And we must not forget to actually pass it into our function, our create function. So there we are. We now have the nice sharp points. One other thing we want to do to the top layer is you can just see the bottom layers peeking out here. It's not quite covering it. So what we want to do is dead simple. We're just going to copy this color, copy that value, and we're going to add a stroke to that path. Use the same color, paste it in there, and now we have a tiny bit of overlap, and you can pump up the width of the stroke as much as you like, which also gives you a nice round end on this end of the top layer. And then this little nick here where the path joins up is just caused by the line join options. That needs to be a round join, and you'll see that corner tidies itself up nicely. So there we go. We're well on our way. Right, let's get some suckers on there next. So we're going to need a new shape layer just to keep things nice and organized. Call this one suckers, and we want to add an ellipse. It's going to need a stroke with a reasonable color. We should be able to make that a bit wider, and then we're going to use these size sliders to just scale it down a little bit. It's probably a bit too thick as well. Something like that will do for now. Now we want to leave the position of this ellipse, these values here, at 0, and we're going to use, instead of moving it around using these values here, we're going to use the values inside this transform, so this position here. And because we're going to want to add more than one sucker into this layer, we're going to create a group. Where are we? Right at the top. We're going to create a group and put our stroke and our ellipse inside there, because when you create a group you get a transform per group inside this layer. So when we duplicate this sucker, we'll get a fresh transform so that we can offset further along the tentacle. Alright, so let's deal with the position first. This one should be familiar to anyone who watched the original video. We're going to need access to our driver layer path. So let's add an expression here to the position. Remember to do it inside the transform, not this position inside the ellipse. So alt click on position. We want to create a path variable just like we did when we drew out the shape of the tentacle. Pick whip down to our driver path so that we've got that. Give ourselves a bit more space. And then we need a few variables. We're going to create one called offset, which is going to be how far away from the driver we want to push down our sucker. Start with, say, maybe 50. We want a path value, which is going to be how far along the path to send the sucker. Start with 0.2, and then what else do we need? Well, we need to actually get the point on the path, which we should know how to do from last time. In the same way, to create our offset, we're going to also need the normal. So let's grab the normal first. So path dot normal on path, and going to put our path value into there, and then we need the actual point on the path as well. So we should be able to do path dot point on path value. I want to add to it our normal times offset. So provided we don't have errors, which we do, of course. It's a typo. Offset. There we go. So that pops it into the right position, and we can just double check that by manipulating our driver curve a little bit. Yep, that seems to be doing the right thing. Okay, so now we need to handle the rotation, which is a little bit trickier. The maths is slightly more complicated, but it's not too bad. It's just a little bit of trigonometry, and After Effects gives us most of what we need pretty cheaply, to be honest. So let's create an expression on the rotation. We're going to need our trusty path variable again, so let's grab that guy, give ourselves a bit more room. Now, previously we used normal on path to position the sucker, and normal on path, if you remember, gives us a vector which is perpendicular to our driver curve at the given point. And what we want is, instead of a perpendicular vector, we want a vector which is parallel to the direction that a path is heading at the point we request. That's called the tangent of the curve, as opposed to the normal. So as you might imagine, we can grab that using the path dot tangent on path, and we used 0.2, I think. This will give us that vector, and then we're gonna apply a trigonometric function to the vector that we get back, which is called a tan 2. And what a tan 2 will do is it will give us the angle between the vector we provide and the x-axis of our comp. So the x-axis of the comp, the horizontal axis, is the kind of reference space. We pass a vector that's parallel to our curve, which might be heading up in this direction, and a tan 2 will give us the angle between that x-axis and our tangent vector. So let's see if we can make it work. It's part of the math library, so we need to do math.atan2, and the way this function works, it's a little bit confusing. You have to pass the y coordinate first and the x coordinate second, so we actually need to bind this to a variable first, don't we, so that we can refer to it in here. So we want tangent 1, which is the y component of this vector, and the second argument is tangent 0, the x component of that vector. And what that will do, it will give us the angle, like I said, between the horizontal axis and the direction of our curve at 0.2% along 20% of the value along the curve. Okay, when I execute this, all is not going to be well at first. You can see that if we manipulate this driver curve, we are not getting the rotation that we expect out of this sucker. And that is because the angle that we're receiving back from a tan 2 is in radians, so we need to convert that to degrees in order to get the expected behavior. Luckily we've got a simple function for that in After Effects. You'll be amazed to realize that it's called radians to degrees. So if we wrap all of this in parentheses and execute now, we should start to see some expected results. Not bad. I think we might want to push this guy down slightly more so it doesn't overlap the top layer. There we go. And that is pretty much it. There's nothing more to it than that. Once you have one set up, it's fairly trivial to just duplicate and perhaps alter the size slightly. You get your new transform group complete with expressions, and all you have to do is change the path values in both your position and rotation expressions. Perhaps make the stroke slightly thinner on the smaller one, but there you go. Sucker's all working. Sweet. Okay, so the next question that I got a couple of times was regarding the shading on this one, and to be honest, it's created with a bunch of effects, predominantly bevels and drop shadows, so we can do a simple version in here quite quickly, I reckon. If we start with the top, oops, we're just going to use layer styles, get some good old bevel and emboss on there, and we want it to be really nice and big so it feels rounded. Soften it right off as well, something like that. Pick some better colours. A little bit cooler in the shadows, possibly even a little bit green, something like that. Shadows a little bit too dark. Yeah, that's kind of the effect. Same on the bottom one. We don't need the highlight at the top. Again, just quickly choose some colours, soften it off so it feels nice and rounded. Maybe it's a bit too strong. And I think on the bottom layer, now this is why it was important for us to bring this top row of points down, because what we can now do is also add an inner shadow. A little bit of distance, soften it off, and now it just looks like this top layer's casting a little bit of shadow down onto that one below, and just, I don't know, giving it a slightly more, a bit more relief. So yeah, you can obviously finesse these values as much as you like, and you can get some quite nice effects by stacking up the layer styles and maybe adding some bevels through the standard effects as well. So yeah, I reckon that's pretty close. Hopefully that's answered most of the questions that I got from the first video. And yeah, I'd like to just show one other thing, perhaps as a little teaser for a future video, maybe just get a few heads scratching. I did actually set up one which is slightly more complicated for a project I've been working on recently, which needed the ability to actually twist along the length of the tentacle. So you can twist from either end and get some quite funky sort of candy cane results going on. The maths that's involved for this one is quite a bit more complicated, too much to go into in this video, but if there's enough interest, perhaps I'll do another follow-up, and we can all just keep making tentacles forever. So thanks very much for watching. Hopefully this one was helpful. I know it was a little bit long, so sorry about that, but yeah, let me know what you think, and yeah, if you want to see more stuff like this, just keep the suggestions coming in. Okay, thanks very much. Bye.